Today, we're going to train a simple neural network using TensorFlow and Keras to classify handwritten digits from the MNIST dataset. This is a classic problem in machine learning and a great starting point to understand the core concepts. Let's dive right into the code. First, let's import the necessary libraries. TensorFlow is our primary tool for building neural networks. From Keras, a high-level API built on top of TensorFlow, we're importing datasets for fetching our data, models for creating the neural network architecture, layers for building the network layer by layer, and utils for some helpful functions. Next, we'll load the MNIST dataset, which contains images of handwritten digits. It comes with training and testing sets. Let's break down what these variables mean. Xtrain is our training images. Ytrain is corresponding labels for training images, the actual digits. Xtest is images we'll use to evaluate our model. Ytest is ground truth labels for the test images. Before feeding the data to the model, we need to preprocess it. We're dividing pixel values by 255 to scale them between 0 and 1. This is a common preprocessing step. We also convert our labels into a format called one-hot encoding. This means representing each digit as a vector of 10 elements, with a 1 at the index corresponding to the digit and zeros elsewhere. This is useful for our model's output. Now, let's construct our neural network. We're using a sequential model, meaning layers are stacked one after the other. The first layer flattens our 28 by 28 images into a long vector. The second layer is a dense layer with 128 neurons. It's where the magic happens. This layer learns to extract features from the image. We use ReLU as the activation function. The final layer has 10 neurons, one for each digit. We use softmax activation here to get probabilities for each digit. Now, let's compile the model. We'll use the atom optimizer and categorical cross-entropy loss function. Before training, we need to configure the model. This is where we define how the model will be updated during training and how its performance will be measured. Here we are using the atom optimizer, a popular choice for its efficiency. As we're dealing with multiple classes, digits, categorical cross-entropy is suitable as the loss function. And we set the metrics to accuracy because we want to track the accuracy of our model during training. It's time to train our model. We are passing several parameters in this fit method. Xtrain and Ytrain are our training data. We are setting the value of epochs to 10, meaning that we'll go through the entire dataset 10 times. We set the batch size of 32, as we want to process data in batches of 32 images for efficiency. Finally, we set validation split to 0.2 to hold back 20% of the training data for validation to monitor performance during training. Notice that, as our model gets trained, the accuracy is increasing and the loss is decreasing after each epoch. After training, let's evaluate the model's performance on the test data. We are using the evaluate method and passing the test data as arguments. We print the test accuracy to see how well our model performs on new, unseen images. As we can see, we achieved the test accuracy of almost 98%. Finally, let's see our model in action. Let's use the train model to make predictions on some test images. We'll make predictions on the first 5 images from the test set and display them along with their predicted labels. This gives us a visual understanding of how well the model is performing by comparing the predicted labels with the actual images. In this code, first, we are importing the pyplot from the matplotlib library for visualizing the images. Then, we use model.predict to get the model's predictions for the first 5 test images. The output will be a list of probability distributions, where each distribution represents the model's confidence for each possible digit. To get the final predicted digit, we find the index of the highest probability in each distribution using argmax and convert it to a NumPy array. Finally, we loop through the first 5 images and their predicted labels. For each image, we display it using the method imShow and set the title to show the predicted digit. Let's visualize the results. We can see the actual image and the digit our model predicts. This gives us a sense of how well our model is doing. As we can see, it predicted 7 for the image of 7, predicted 2 for the image of 2. In the image of 1, we can see the handwriting is different. Still, it predicted the correct digit. And similarly, it predicted the correct answer for 0 as well. And that's how you train a simple neural network using TensorFlow and Keras to classify handwritten digits from the MNIST dataset. Thanks for watching. Don't forget to like, share, and subscribe for more AI Bites. If you have any questions or want to see a specific topic covered, let us know in the comments below. See you next time.